Hello, my name is Joshua Tyler, and after some consideration of where I want to go with what I'm doing now on YouTube, and I think so a lot of my work involves using Mathworks, MATLAB. So I think what I want to do is create video tutorials starting using MATLAB's Cody, which is an online teaching tool for new coders to get introduced to MATLAB and see exactly how it works. So what I'm going to do is start at problem one and then go over and explain how these function how I'd solve these functions and hopefully um, teach some new beginners on how to use MATLAB. MATLAB is um, a very useful tool to a lot of different applications. So I use it for machine learning and digital signal processing. There's other people that use it for image registration, most notably like object detection and autonomous vehicles. So that's a lot of object detection, multi-object detection in the same image. So that's probably multiple neural networks or multiple convolutional neural networks all working in parallel with each other in order to discern different objects and then make decisions um, in order to drive. So that's a big one. It also has finance. It also has function fitting. It solves ordinary differential equations. You can do quite a bit on MATLAB, and it is starting to become the number one tool for machine learning, just because of how easy it is to approach machine and deep learning on MATLAB. So, with that in mind, I would like to help onboard people onto MATLAB and help give younger people the and potentially older people, looking to get into coding, kind of a tutorial and how to get onto it. So, with that being said, let I already solved number one. So this is MathWorks Cody. So anybody with a university license, typically any kind of public university, will have a MathWorks license. I'm not exactly sure if you have to own MATLAB in order to do this, because I just use my university license, so that may be different. But anyway, you know, it may be just something that um, I'm not exactly sure. So your mileage may vary with using MATLAB Cody. But anyway, let's go to first one that I solved. So test two. So this is essentially so multiplying any input by 2 and then returning the output. So let's click on solve here. So we say input x equals 2, output y equals 4. So remember, if we just want to multiply 2, remember y equals 2x. So here we define function. So we're saying that this is a function, which means the only way to run this is by calling it from not the same file. So this defines the file as a function file, so we call this file from the actual file that we run our script in. So, like, we'd say, so like in another file, we'd say, um, so we have an input y, and then we say, or we have an input x, we define our variable x, and then we say y equals times 2x, just like this in our other file. So here we want to modify the line below so that the output y is twice the incoming value x. So all we have to do there is just say 2 and then times. So the little star, if you press shift 8, you'll get that star on the keyboard, and that should multiply it by 2. And this end says that we're ending, so we're ending the wrap on that function. So a wrap, WRAP, is essentially a slice of code, beginning and end, that has a certain function. So something like an iterative loop, a conditional loop, is wrapped with the beginning statement, whether it's like for, while, if, and then it's ended by typically an end statement, and that wraps the function, and that wraps y equals 2 times x. So now we will run this function, x equals 1 plus 2, so we should get 3 there. So this is what the file that you actually run looks like, and this is the called file. Okay, so we have output x equals 3, okay, and then our answer equals 6. So that is by 6. So we have a test here. So assert is equal times 1. So input 1, so we should get 2 there. If our input is 11, we should get 22 there. If our input is -3, we should get -6 there. And if our input is 29, we should get 58 there. So this, so let me just explain this. So this section here is times 2. So that's the function that we created up here. And then is equal returns a logical yes or no. So if the two numbers that you put separated by a comma here are equal, it will return a logical 1. And if the two terms that you enter separated by the comma are not equal, it will return a logical 0. So let's go ahead and submit that. And I forgot exactly what assert does, but let's see. Assert me do. Okay, so assert, all it does is it checks. So for a logical 0, it returns an error and stops the program. And then if assert is logical 1, it continues on. There's no error. So that's how that works. Okay, so you can't improve that code. Okay, so now let's go to problems. Let's go to problem 2. So in MATLAB, you create a vector by enclosing the elements in a bracket like so. So this is called an array typically. So, um, so if you hear vector, that means the array is no, it's two-dimensional. Well, it's okay. So like when we talk about our math, we have like a line we're saying that's one-dimensional, and a square is two-dimensional, and a cube is three-dimensional. Now here we have yes. So effectively, we're saying this is a one-dimensional. A vector is a one-dimensional array, and then um, so a vector is an array, but a vector is an array, but an array is not a vector, if that makes sense. So a vector is a 1D array, and then arrays can be however dimensions you want. Typically, you want to avoid doing like a 10-dimensional array. That would get really confusing on indexing. So commas are optional, so you can type that. So if you're not sure, if you want to be sure that things are being indexed in the right position correctly in the vector or array, then you can delimitate it by commas. And then you can create the vector by saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's solve that. Okay, so x equals 1, 2, 10. So what do they want us to do? So So there's two ways of doing this. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let's run this. Run function. Okay. So get an array there, but there is a much easier way to write this function or to type it out. So let's say that we want to, okay. So if we look here, the distance between each of the elements of the vector are the same. So like 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1, so on and so forth. And we're starting on 1 and ending at 10. So if we erase this and just saying 1 colon 10, the default, so let me write it like this. So the way you would read this is 1 in steps of 1 to 10. And that creates a vector Or yes, that creates a vector from 1 in steps of 1 to 10. Now, if we wanted to say, well, let's use um, 1/2 steps, I would say 1, 1/2, 2, 2, 2 and 1/2, so on and so forth. Here, you just want to say 1 to 10. And this is really helpful if you want to create a very long array and it's a continuous step. Well, it's a uniform step size in between each element of the array or the vector. So let's run that also, and we get the exact same answer. So that's a simplified way of saying x equals 1, 2, 3, 4, 5, 6, 7, 8. Let's see, what is it? 9, 10. Same answer, different inputs. It's just easier for the user when you're coding it. Okay, so test 1 is passed. Okay. This doesn't mean anything. Okay, so let's go to problem 3. Okay, x equals 1, 2, 3, and 5. Output is 11. So does that sum everything? Find the sum of all numbers in the vector. Input equals 4. Okay. So all we do there, vector sum, simply enough, we will run the command. Well, we'll call the function sum, which sums all the vectors, and then you sum open parenthesis your input x close parenthesis. So let's 3 y equals 3 answer equals 3. Okay. So let's see what happens when we submit that. Okay, pass all tests. There's another way. So here's, let's say, let's do it in a more complicated way and show how MATLAB is actually doing this. So we'll say for so we'll open that iterative loop, I as the iterant equals 1 to length of x. So let's see, we need to say at first y equals 0, and then we'll say y equals y plus x of I, and we should get the same exact result. So here, what we're doing is we're finding the length. So here we're starting y as 0 because we can't, for the first one, if we say y equals y, we're calling in a variable that doesn't exist. So we have to initialize the variable y first before we start the loop. And then when we create the loop, we're saying length of x, so that just returns, so x will be a 1 by n vector. So we're saying essentially for I equals 1 to n, and then we're saying y equals y plus y, and that iterant I is moving indexes incrementally up from the first element of the vector x to the last element of the vector x. Okay. Size 16, leading solution size is, okay, so y equals, leading solution size is 10. So that's just to show you that what MATLAB is doing. Triangle numbers, okay. Triangle numbers are the sum of successive integers. So 6 is a triangle number because it is 1 plus 2 plus 3. So, which can be displayed as triangular shape 1, 2, 3. Triangle 3, give in, return t. So if n is 4, it's 1 plus 3. Okay, given n, return 3, the triangular number for n. Okay, t equals, okay, okay. So here we go. Okay, now I get what they're saying. Okay, so what they're saying is, well, it's essentially adding up from. Okay, so let's say if I input 3, I'm going to add all the numbers from 1 to 3. And then if I input 4, I'm going to add all the numbers from 1 to 4. So I'm going to say t equals sum 1 to n. Function. If I say 4, run function. Great. So I'm saying given n, t is the sum of 1 to n in integers. So integers are whole numbers. So 0, 1, 2, 3. Um, so let's see here. So there was an issue where they had n here. So let me run that function again. This is probably just MATLAB's fault or Mathworks' fault. So here we actually need so we see unrecognized function or variable for n because in this code in lines 1 through 5, n was not defined, but x was. So we'll change that to x, and we'll see. Okay, so here, okay, so they initialize t and n. Okay, so let's submit that code. Awesome. Select every other element of a variable. Okay, so output is 1, 2, 3. Okay, so this will be interesting. So we can actually do every other. So we'll do downsample x 2. Let's see, run function. Let's see what it says. Undefined function downsample for input of argument type double. Well, x should be okay. Okay, so here's what we'll say. Select equals 1 through and we'll say step size 2 to length x, and then y equals x of select. Or let's just simplify here. 1, 2, 2 to length x, and let's submit that. So, like I said, that step size when you use colons, that can be useful. The default is 1, but you can also do it by 2. How are people getting that in 10? Okay, so they're cheating. They're using regex for everything, and they're taking all the fun out of it. Column removal. Okay, so let's see how we do this. So n equals 2, so we want to remove column. We want to remove column 2 out of it. So let's say this is an array. This is no longer a vector. So column removal A. So let's say select equals 1 to size A 2. Select is equal to select of select not equal to n. And then we'll say B of A of select of colon to select all, and then select. See how that works. Okay, so what I said here is I created a new vector called select, which is 1 to size of A2. So the size command will find this will find the size of an array. And if you use size of A comma 1, that finds how tall the array is, so how long each column is, and then size 2, well, size 1 will find out how many rows there are, and then size comma A comma 2 will find out how many columns there are. So I said 1 to however many columns there are in A, and then I said select equals select of select not equal to n. So let's say A is uh, let's say that A has 10 columns. So then I'm saying create a size array that's, well, create a vector called select that is 1 through 10, or the size of the number of columns in A. And then I say, okay, so for every value in that vector select that is not in, I want to keep that and then return that back as select. So then here, um, B equals A. So when I open that parentheses, I'm selecting elements of the array A, and with that colon, I'm saying in the colon in the first part of that indexing, I'm saying every single row, and then in the second part where I'm saying select, I'm saying take everything but column in. Where am I on this? On 24 minutes. I think I'll cut it off at 30 minutes. Um, okay, add two numbers. Okay, so here we have two numbers, A and B. C equals A plus B. That should be easy for obvious reasons. They're using that regex. Sure how I can get that any smaller than c equals a plus b, but okay. Um, let's see, make a checkerboard matrix. Okay. So n equals 5, so it'll be 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. Okay. Okay, so 5 equals 0, 0, 1. Okay. That creates an array of ones. Okay, so let's not use that. Um, okay, so what we'll say, saying 1, 0, 1, 0, 1. So let's say start array equals 1. See, how do we get the alternating 1? 1. And if I see, does MATLAB have there's no built-in function. So let's say if -1 to say if -1 to the power of I, so if I is even, then it will be less than 0, and then if I is odd, it will be greater. No, if I is even, it will be greater than 0, and if I is odd, it will be less than 0, is less than 0, so we're saying it's odd. Start array of I equals 1, else start array of I end, end, and then see I equals 1 to n. If I equals 1, then a of I equals start array, else a of I equals search shift start array 1. And here I'm going to make easier on the memory. And what I'll say is start array equals zeros, 1 through n, and then I'll say a equals zeros, n by n array. So let's say n equals 5. Let's run this function and see. Well, let's say odd array, even array of I 0, then even array of I equals 1. We'll say odd array, and this will be even array of zeros, 1 in. Odd array. If -1 to the power of I is less than 0, one function Okay, let's do something else. Okay, so let's say function a equals checkerboard in. Let's say odd index equals 1 to 2 to n. Even index equals 1 to 2 through 2 to n. In. Okay, now let's say a of odd index um, a of odd index will equal, let's see, ones. One equals ones n by n. Say 1 by n equals 1 array of odd index, and then a of even index equals 1 array of even index. End. Five, column 19, line 5, a of 1 index. see, where's the scratch pad? Okay, so let's comment this out. So let's see, one array equals ones, ones, one, comma, in. Okay, and let's say odd index equals 1, 2, 2, 2, n. And function. Solution.m. 5 column. Let's cut this out. One array. Okay. Why is odd index? Oh, so let's say one array of odd index. Let's see what that returns. Here we go. Okay. That's why. Okay. Here we go. Of odd index equals 1. See if that works. There we go. Okay, so odd column index is 1 to 2 to n, and even index is 2 to 2 to n, 2 and steps to 2 to n. I'm just saying a of odd index, comma, odd index, so that's saying, well, essentially, just saying odd rows, odd columns, 1. So let's submit that and see how it reacts. Awesome. I'll say that was a medium. Okay, well, I think that's all I want to do for today. See you later if I do.